looking at limits, and I want to do some of this visual stuff. We covered a little bit, and we're going to cover a lot more on the algebra version of calculating limits. But remember this guy? Here is a function, vertical asymptotes. And in this case, the limit as x tends to 2 on both sides is infinite. So we would say this one diverges, as they all do, but we would in particular, you could also say that this one had a limit of plus infinity. On this second situation, because on one side it goes up, on the other side it goes down, as you approach 5, x equals 5, there's no distinct, one's not better than the other, so this one just simply diverges. So what I have here is another kind of limit, visual limit, and let's look at how you can just look at the picture and find out what the limit as x tends to 3 of this function is. I better put my little dotted line so you know which one I was trying to point at. That's that one there. Here is a function with a little hole in it. Have you ever seen those kind of questions where, like an irrational function that we did on the calculator, there was a funny little gap? Remember that? That gap's considered a hole. It means the function's undefined there, right? So can you imagine there's a little hole in this graph? Wouldn't it make sense that the limit of this function is 5? Now, if I asked you to find the limit as x tends to 5, which is this picture, do you see that there's a definite jump, right? There's a problem from here to here, right? It's a piecewise function. In this case, you would say that the limit does not exist. Are we comfortable with, if I showed you a picture like this, you would say the limit as x tends to 3 is 5. And if I said to you, what's the limit as x tends to 5, you would say it does not exist. Now, you could say diverges, and that actually would work. But in these cases, we're giving you other terms. It does not exist is probably a better definition of this situation. Diverges tends to be used, not exclusively, but tends to be used when things go infinite on you. Now, we are going to look at what's called a left limit and a right limit. If you hold on a second, that's something I need to do first. There we go, got some background sound. It's slightly distracting for me. And it should be back any moment. Here we go. Right, so we're going to look at what's called a left limit and a right limit. Let's do a left limit first. This is how you write a left limit down. It's the limit as x tends to 5 with a little baby minus on it. It doesn't mean -5, it's just a little baby minus, right? A little negative. And that means the limit of the function as x approaches 5, but coming in from the left-hand side, right? That's coming in from the 4.999 side. And that's called a left limit. We have a guy on the other side called a right limit. And the right limit would be written using this notation, but with a little plus on it. So that would be, you're going to see what the value of the function is trying to become as x gets closer to 5, but coming in from the right-hand side, coming in from the 5.0001 side, okay? Well, let's look at this picture here, because that's one I designed it for. Oops, there we go. This is f of x, right? There's a bit of a bump here. If you were coming in from the left-hand side, do you see that the answer that you're trying to become is 10? Does that make sense? The value of the function as you get closer to x equals 5, but coming in from the 4.99 side it's going to get to, or at least try to get to that point there, which is at height of 10. What would the right limit be in this question? Well, you're coming in from the right-hand side, and can you see a little hole there? And that's meant to be at 4. Now, do you notice that those are different? One is at 10 and the other is at 4. Does that make sense? Coming in from one side, it's 10. Coming in from the other side, it's at 4. That's the difference between a left and a right limit. Now, let's, oh, still a picture. I'll put it over here. If I went—
I have a question.
Yes.
So the reason why the limit that, like, as x approaches 5 doesn't exist is because there are two different numbers
You
that
nailed it.
the y-axis could be. Okay, I just want to be sure.
No, since you've said that, let's put in. They are different. This means, and it will mean it every time this happens, that the, you'll hear me call this the overall limit now, that the overall limit as x tends to 5 does not exist. Does that make sense, that if the left limit's not the same thing as the right limit, the curve's got a break in it, right? They're not going to meet in the middle at one given point. Now, if you look at this fella here, if I do the left limit, the answer is 5. If I do the right limit of this function, isn't the value of the function also trying to be 5? And when they are the same, this means that the overall limit exists. And not only does it exist, won't it be equal to whatever those numbers are agreeing on? Does that make sense? If the left-hand side is going somewhere and the right-hand side goes somewhere, but they meet at the same somewhere, isn't that somewhere the limit? Right? So they meet at a height of 5 or they meet at a height of 25, it really doesn't matter. And that is left limits and right limits. So it's still limits, but a little bit of nuance here, right? You can have an overall limit, which is basically written using that notation. So let's have a look at this vertical asymptote guy.
Does it, so
yeah,
the limit, it says x arrow 3 and then it's negative. So is it like -3 and -5?
No. What that means is it's coming in to the left from the left of 3. So that's like 2.999 side. And this is coming in from the right-hand side, the right of 3. So this is like 3.001. So if I bring this picture in, if I was wanting to find the limit as x tends to 3 minus, I'd be looking at this function and I'd say, okay, I'm coming in from the left-hand side. Do you see the answer here would be 5? So it doesn't mean x is -3. It just means x is coming in from the left-hand side of 3, coming in from the 2.99 side, right? That's the left side, and you're approaching from the left. Does that make sense? That's what that is. Yes. That's what that's.
So it has nothing to do with positive or negative. It just
no.
The negative is left and the positive is right.
Yeah. It kind of, yes, you're right. It has nothing to do with negatives and positives. Isn't it more to do with a little bit less than 3? That's why it's negative, or a little bit more than 3. That's why it's positive. So it's good. I think it's a pretty good notation, right? Now let's go and look at this fella. Let's do a left limit on somebody. What would be the left limit as x tends to 2? Well, would you agree that as you come in from the left-hand side, isn't the answer plus infinity? And plus infinities are okay right now, right? That is a valid answer. What would the right-hand limit x2 plus look like? What would its value be?
It would also be plus infinity.
And since these are the same, does it not mean that the overall limit exists? And won't it be called Somebody, man, a leaf dropped outside. It doesn't take much for Bailey to get inside. But do you, left and right limits are the same. So the overall limit equals whatever they are equal to. Right, let's do this guy. The limit as x tends to 5 minus. And the limit as x tends to 5 plus. Let's see these two. Okay, what would the limit as x tends to 5 minus on this fella be?
Infinity?
Right, great. And what would the right limit be as x tends to 5 plus in this case?
Negative infinity?
And those are different, aren't they? And if they are different, don't we just say the limit does not exist? The overall limit does not exist. Are we beginning to get a little bit more comfortable about left limit, right limit, and overall limit in the sense of visual graphs, right? Looking at pictures. Are we good?
And so for any of the ones that you said, like the special limits when they diverge, is it also like we could also say that they don't exist?
If in your world infinity does not exist as a number, yes. The language is a little bit grey there. In my brain, I tend to use diverges more in the sense that it's a catch-all for everything diverges. It doesn't have a number. Right? That's just kind of the way I like. So everything's a diverge that doesn't have a limit, right? But in the context of these, we want to be able to say infinity if infinity exists, right? So, you know, we're bending the rules. Yes, it diverges. Oh, here's a way around it. It diverges to infinity. How about we could put both in the same sentence? Now, when I say does not exist, I'm being much more pernickety about that. I think does not exist should be restricted to, you know, the one where it's up here and then it's down here, a distinct break in the graph. That is a does not exist situation. Can you imagine the cosine of n if you travel to the end of the universe? That later on you're going to be looking at those limits, and those would be do not exist. I believe when you're doing the homework, they tell you which phrase you want. So they will also tell you if it doesn't, then say it diverges. Or if it doesn't, then say, you know, DNA, right? They'll kind of tell you. So you don't need to worry about it. I want to show you some questions from the homework. The best reason for me to do that is that they're much better at drawing pictures than I am. And it gives me a chance to, you know, kind of look at them, and all of us to look at them and kind of see what WebAssign does. Now, have you noticed that in this case, they're saying use DNA, right? So that means your answer could be, you know, 4, 44, infinity, minus infinity, or does not exist, right? So you get choices. So let's look at some of them. In this one here, oops, shrink back a bit. I want to see more than one question. There we go. Is this a left or a right limit you're looking at in question A?
Left limit.
It's a left limit. You agree? Would you agree that's a right limit? And would you agree that's an overall limit? Okay, so let's look at this question. And in particular, if you look at -3, do you see it's there where that little circle is, that little hole? If I asked you to tell me what the left limit is, you'd be looking at this function coming in from the left-hand side. And as you get closer and closer to -3, isn't the value of the function, its height, and its height is 4. That one is there. Now, if I asked you, I have to shrink it a little bit more to see that. If I asked you to do a 3+, what would the answer be now? Also 4,
Also
yeah,
4.
it's like, yeah. What would the overall limit be?
All 4.
Of 4. Does that make sense? If the left limit and the right limit are the same thing, everybody agrees with each other. Now, be careful. This is the value of the function at -3. If you're being asked to find the value of a function at -3, when you look at this one, isn't there a little hole? So you do not write 4. Because there's a hole there, that is saying the function is undefined at that point. So you write down DNE, it does not exist. So see how the DNE can be used here, you know, to decide what your answer should be. Right, let me use this guy right now. What would be the left limit as x tends to 2? In fact, I can make this picture a bit bigger. The left limit as x tends to 2.
2.
2.
Would you agree the right limit is also 2 and that the overall limit is 2?
Yes.
Yes.
What would h of 2 be?
Diverges.
DNE.
DNE.
Undefined.
Right, right. We're hearing all the different words, and undefined is correct.
Type.
Technically, I wouldn't want to use diverges because I like that for other situations. Right, the DNE is what they want. Does not exist. So you know, if you put any of the others in, it'll probably tell you that you're wrong, even though technically you're right. Now this one here, the next one I'm going to do is going to hurt your brain. X tends to 5. Do you see x tends to 5 here? This function is doing some weird stuff. If I asked you for the right limit, I'm assuming that it gets to where my finger is, but mouse is pointing, which I am saying is a 3. So if I asked you the limit as x tends to 5 plus, right, the right-hand limit, you should say 3. Right. What about the left-hand limit? Well, it's not obvious what's happening here. Can you imagine a sinusoidal curve that the closer and closer you get to 5, the tighter it gets, but it still zooms up and down? An example of a function that does that. Can you imagine sketching sine of 1 over x on your calculator? As you get closer to 0, doesn't it continually to zigzag up and down, but it never really homes in any one place? What you have got here is the left limit does not exist. It's kind of hard to see. Doesn't it look like a solid blue at the end? And the reason it looks like a solid blue, isn't it infinitely going up to 1 and down to -1 forever? Even although it's a confined space. So does not exist would be the left limit. What would the overall limit be then?
Does not exist.
Exactly. Don't you only get an overall limit when both things are the same thing? They're both numbers, or they're both infinity. And if they're going to both infinity, don't they both have to be plus infinities or both have to be negative infinities? Right. Okay, let's skip to our next picture. A little bit cleaner because there's less going on here. And I'm only going to ask you a couple of questions this time. What is the overall limit as x tends to 2 if it exists?
It's undefined.
And what will we use instead of the word undefined, which is correct?
Does not exist.
Right, DNE.
DNE.
Right, you're totally correct, but you know, I keep WebAssign happy. What would the overall limit as x tends to 4 be if it exists?
4.
4.
Agreed. Right, that was easy. What is the overall limit if it exists for x tending to 1? What was that number you said? Look at Lucius.
I didn't
I
say
thought, oh, I thought it was you. Someone said something, but I didn't quite catch it. What is the overall limit as x tends to 1 in this graph?
Does not exist.
No.
2.
2. Sometimes the simplest ones can throw you. isn't my mouse pointing exactly at the overall limit? If you are a normal function with nothing weird going on, isn't your overall limit just the value of the function? Wouldn't the left limit and the right limit and the overall limit be the same number if it's just a nice curve and nothing weird is going on? So for the most part, isn't that curve got its own answers? Now, there's something fun going on in the 3 one. What is the left limit in as x tends to 3?
DNE.
1.
1. Now, you're going to say, and I can understand it, but you said there's a circle there and circles means it does not exist. Well, that's for the value of the function, but it's not for a limit. A limit can equal something even if there's a hole at the end of the curve. So in this case, the left limit is 1. What will the right limit be now?
4.
Right. Even although there's a little hole there. What about the overall limit as x tends to 3?
Doesn't exist.
Doesn't exist. And be careful with this one.
So that's
What is f of 3?
f of 3 is 3.
Right. Do you see in this case there is a dot? So the value of the function. In fact, isn't the value of the function probably got nothing to do with the rest of the curve? It's kind of a random dot that they stuck there because they wanted to. So isn't it possible for you to have an overall limit equal to one number and the value of the function at that point being something totally different? I mean, that is possible. Let me show you that. Here's an example of that exact thing happening, what I just said. Can you imagine a function that looked something like this? And that was 10. And that was 2. And this is 5. And way up here to 18. In this question, that limit, the left limit, would be 10. The right limit would be 2. The overall limit would not exist, DNE. And lastly, the value of the function at 5 was 18. That's one situation. Here's an even weirder one. The left limit is 5. The right limit of this function is also 5. The overall limit, since these are both the same, exists and is 5. But isn't the value of the function at 3 not 5? So the overall limit of a function doesn't necessarily have to be the value of that function. Would you agree in this weird situation, the value of the function is quite random. It's a way up for no particular reason at 10. So there's a little nuance to be aware of. The value of a function doesn't necessarily always have to be the same thing as the overall limit. Okay, here's one with some infinities in it. What is the overall limit as x tends to -3?
Positive infinity.
Overall limit as x tends to -1.
Negative infinity.
Agreed. Overall limit as x tends to 2.
Does not exist.
Left limit as x tends to 2.
Negative infinity.
Negative infinity.
Right. Are we getting more comfortable about left, right, and overall now? Right, if I give you a picture, can you imagine what a left limit might be, a right limit? This one happens to be with vertical asymptotes, which is kind of nice. Okay. A patient receives 150 milligram injection of a drug every 4 hours, and the graph of the amount of the drug still in their bloodstream after T hours is given by this. So they get 150, and then 4 hours, your body metabolizes it, uses it, and then you get a booster, and then it uses it, and then you get a booster, and then you use it, and then you get a booster, and then you use it, and then you get a booster, and then you use it. If I was asking a question about this, I could ask you something like, what is the left limit as X tends to 8 hours? What is the left limit as, or I should call it T. What's the left limit as T tends to 8? Well, I wish I'd give you that question a little bit easier. Say about 130, kind of answers the question. What's interesting about this is, if you were wanting to give someone a large amount of antibiotics or a large amount of whatever it is, isn't it quite dangerous to just give them it all at once? Because it might just overwhelm the kidneys, the liver, give somebody a heart attack, right? But you still want to give them a large dosage of it. Can you imagine that if that was the case, wouldn't it be easier to do it the way they're doing it? Just give you so much, wait 4 hours, give you a little bit more. Because if you look at this, isn't there still a trend of going upwards? Can you see that after whatever that is, after 24 hours, isn't that person still going to be, over in the 200s now? And if you continued with that regimen, couldn't you get up to hopefully a safety limit? Couldn't you get a lot of that drug into someone's system, but not shock the system by giving them it in one big jack? So you can imagine that there could be practical uses for this way of doing something. I believe the modern ones, don't they have the diabetic pumps where instead of giving you a big jag of insulin, it kind of gives you little doses, but lots of them, every hour, a little jag, a little dosage, every hour, another dosage. And that's much safer and better for a human, isn't it? Than getting, one huge injection at a time. So that's a pretty cool question. Oh God, look at this one. It looks like spaghetti. So let's ask this question a different way. Give me any value of X where there's an overall limit of plus infinity.
As X
0.
approaches 0.
Agreed. Is
3.
and -3. Give me any value of X where the overall limit is negative infinity.
-7.
Agreed. Is there anywhere in this graph where the limit, the overall limit, is or does not exist?
6.
6.
Agreed. I'm feeling comfortable with this. I'm getting the vibe that we're looking good, right? Okay, so I want to now move on and talk a little bit about the algebra, because it's been a while since we did the algebra. So we've seen a lot of graphs, which is nice, but that's not the only way in which you're going to see information. So let's look at finding limits using the algebra techniques. Now, to remind you what the algebra techniques are, in no particular order, there's a method called brute force, which is basically just plug the number in, and if you get an answer, that's your limit. The second method, we did at least a couple of these that I recollect, it's called the factor and cancel method. And the third one you haven't seen yet, you will eventually, it's pretty rare, but you will see it. It's called the conjugate method. So let's have a look at this fella. Now, if I tried brute force, wouldn't I just put h equals 0 and see what we get? And can you trust me that when you put h equals 0 into this expression, you end up with 0 over 0, right? 0 on the top, 0 on the bottom. And we call that indeterminate form. It really means bad news, ain't going to work. Now, I could certainly do some factoring and cancelling, which is going to be the method that will be used for that. If you want to know when on earth am I going to use a method, I don't even know what it is yet, called the conjugate. Do the conjugate only when you see square roots. So if you ever see an expression with a square root in it, it's probably going to be the conjugate method. So I've tried brute force, it failed. I know it doesn't have square roots, so it can't be this one. So evidently then it has to be the factor and cancel. But sometimes you have to do something before you can do that. Any ideas what I might do to this expression? What might I do to this to make it easier to deal with?
Factor the h minus 4 squared.
Okay, and can you hopefully trust me it ends up being that? H minus 4 times h minus 4. And if you collect like terms, something really nice happens. Looks like that, right? Okay, now I think I can do factor and cancel. Hopefully you can tell me what to factor. Agreed. And if you take out h as a common factor, won't you be left with that guy? So there's the factor part done. And then don't we do cancel? And when we cancel, we end up with
H minus 8.
Exactly. So we now have an algebraic way, right, of finding the overall limit. Have you noticed that these questions are back to overall limits again, right? Let's try this fella. And this fella is going to use the graphing calculator. So we're not going to do factor and cancel. And we are going to use our graphing calculator to find this guy, and that guy. And I'm just going to call it f of x, so I don't have to write all of that. And it does say use the graph of the function. And I did say graphing calculator, and you certainly can do it with a graphing calculator, but I'm not going to. I'm going to use a lovely piece of software that I like a lot, because I'm a visual learner. I like to see pictures. And my calculator is not, unless you've got a really fancy colored one, is not the best way to visualize it, right? The picture's not very nice. It's kind of small and clunky. So if you give me a few moments, I'm going to show you the thing. It's called Desmos. You ever use Desmos?
Yeah.
Desmos is so cool, isn't it?
Yeah.
I mean, it just does the job much better than our calculator, in my opinion, than the calculator does. So I'm in Canvas right now. Oh, there's my brother-in-law. In Canvas, and I'm almost there. Right, here we go. Let me show you where it is. I never find that things when I want them. Here we go. Right, you should be looking at a blue Desmos. Can you see the little baby Desmos? Right, fingers crossed that it doesn't go wonky on me. I'll click on it. Yay. Okay, so I should be able to just type in y equals, bring this thing up, and well, I should be able to do it with a bracket. Right, so a bracket, I believe I can do e to the power of, what do we want? 1 over x. Interesting. Subtract 5 Right, that's the top guy, put a little division symbol, and then e to the power of 1 over x again. And add 1. And I don't need that. Now, that's pretty nice, isn't it? But I'm only really interested in what's going on round about 0. Would you agree that coming in from the left-hand side, the answer is what, -5? You agree? So although you can't see me, I'm writing -5 down right now. If you do a right-hand limit as you approach 0, isn't the answer 1? And in that case, then, doesn't the overall limit d So if you look at this function, before I sketched it, wouldn't you describe that as like a piecewise function? Isn't it a broken function in 2 pieces? Right. Even although it didn't come from, you know, the usual piecewise function is x squared when x is less than 0 and sine x when x is greater than 0. That kind of look about it. It doesn't have 2 distinct functions, yet nonetheless, it's a piecewise function. So do you see functions can have problems, can't they? In places you don't expect them to have them. Like this function here might have looked a bit weird, but you wouldn't have thought it had a problem at 0. And it wasn't until you did Desmos that you even discovered that quite major hiccup. Okay. So the left limit was what, -5? The right limit was 1. And the overall limit does not exist. Are we comfortable with that question now? Yes.
I have a quick question.
Sure.
Is there a reason that I wouldn't have maybe tried to use brute force on this first, other than, you know, wanting to?
Oh, that's a good question. They told you to use a graph, so that's why I did it. But let's have a look at what she was saying, because Rachel was saying, could I not just do brute force? I'm about to have a shot at that and see what happens. Right. Now, if I wanted to do the overall limit, or a left limit or a right limit, and you want to put 0 in here. So let's see what we get. That's on the top, right? And that's on the bottom. Agreed? Now, what does 1 over 0 get you? If you take 1 and divide it by 0, don't you get infinity? And would you agree that e to the infinity take away 5 is still going to be infinitely big? And won't e to the infinity add 1, isn't that also going to be infinitely big? Do you see that the brute force doesn't work, unfortunately? But sometimes you don't know until you've tried, right? So you've learned something. This one doesn't work with brute force, but maybe the next one will. Next fella we're going to do is numerical. I'll have to be pretty quick with this one. So we're going to find numerically what our limit should be. Actually, when you do it numerical, it's really an estimate of what the limit should be. So let's suppose I wanted to know the limit as h tends to 0 of 2 plus h cubed, take away 8 over h. Now, I could do that by foiling the whole thing out and factor and cancel. And if I did, I would get the right answer, right? I would have got an answer. But they are wanting us to do it differently. We are going to basically evaluate this function at lots of different places. So it's going to be at -0.5, -0.1, -0.01, got -0.001, and -0.0001. I'll put in 0 as a placeholder. Trust me, it doesn't exist, so you can't actually evaluate it. And then you're going to do the positive versions of all these guys. Right. Since I don't have enough time to finish the thing, can you imagine what the rest would be? And the last one you would write would be +5 down there, right? And we are going to evaluate this expression at all these various points. Do you notice that, at least the way I've written it, as you do this direction, aren't you getting closer and closer to 0 coming in from the left-hand side? And then as you do these ones, won't you get closer and closer to 0 coming in from the right-hand side? Now, since I'm a lazy or efficient person, yeah, I like to do things efficiently, let's get the calculator to do as much of this work as we can. So I'm going to go bracket. I need a bracket, and I also want to then do another bracket, and I'm going to call it 2 plus x cubed. Subtract 8. Then I can close that bracket. Then I'll divide, and on the bottom I'll just put x. And then I'll do my table setup. And I'm interested in 0, so I'll do that. And that's a table setup, then second table. And I don't like these guys, so I'll rub them out. And negative 0.5, and negative 0.1, negative 0.01, negative 0.2 zeros and a 1, and negative 0.3 zeros and a 1. And then I'll put a 0. And then I'll put 0.12, 3 zeros and a 1, and then 0.2 zeros and a 1. So can you imagine I do the whole table? Now, some of the earlier numbers are about to disappear here. But when you look at this table, do you see, as you get closer and closer, and a little bit, you can see the other one as well, can you? Eventually, I hit enter. No. Right. Can you see that there's an overall limit happening? What would that limit be if you were a gambling person?
Well,
I would agree, 12. So do you see that my estimate based on a table of values, aren't these last two ones the ones that are really making up my mind? This one here is 11.999, and this one here is 12.006. Would it seem reasonable that they meet in 12? Would that seem reasonable? Right. So far, so good?
I have a question.
Yes.
Could you show how you input it into the y1 equals part again? Because I was
Sure.
getting different answers in the table setup.
Right. So you put in a bracket first, and then another bracket, and you type in the top line.
Okay.
Then you close the bracket, you then do a divide, and then you put X in the bottom.
Gotcha. I just missed a bracket.
Bracket, yeah. These things are very pernickety. In fact, it's always a good idea to have more brackets than not enough, just to keep it safe. Are we comfortable with that process then?
no.
Now, engineers probably do everything with numbers because they're comfortable. Aren't mathematicians much better if we can do it algebraically? So for the last few moments, and while I'm doing that, you might want to say hello with your name. So write in your last name in the chat, and here goes. If you FOIL out 2 plus h times 2 plus h plus 2 plus h, you will get 8. What else will you get? You'll get 6 h's. You'll get 2 h squared, and you get an h cubed. Take away h all over this guy. One of these numbers is wrong. Which one is it? Oh, it's this one. This one is 12. I made a mistake. Right, and so you will get the limit as h tends to 0 of 12h, 2h squared plus h cubed over h. You can then pull out a common factor of, in this case, h, because we're doing the factor and cancel trick. when you cancel, you're now left with this guy. And now you can plug in zeros and Bob's your uncle. This to me is very clunky and time consuming. This is just more elegant. If you can do factor and cancel, isn't it just more elegant? Now, can you do every limit in the world that way? No. Can you imagine somebody writes down just the ugliest looking function in the world, right? Sine x plus e to the x over x cubed and all sorts of stuff. In those situations, wouldn't you have to resort to a table of values? Because you can't factor everything, even if you wanted to. And that's why this method is even taught to you. If we didn't need it, we wouldn't bother even going there properly. But there are going to be some situations, so just off the top of my head. If I went and asked you to do that guy, would you agree you can't, well, make that a 4. Would you agree you can't factor it? And you can't do anything else to it. And if you try brute force, you get 0 over 0. So that's how, and there isn't a square root, so you can't do that. So you're stuck, aren't you? Wouldn't that one have to be a table of values? And actually, you know, the reason you do a lot more isn't it to make sure that you see a pattern, right? You get an idea of what's it like coming from the left and what's it right coming from the right. Because if you didn't, couldn't you get one of those where it's 10 on one side and -5 on the other, in which case the overall limit doesn't even exist. And that is us for today. So